Welcome back to Mining of Massive Datasets. We're going to continue our lesson on recommender systems by looking at content-based recommendation systems. The main idea behind content-based recommendation systems is to recommend items to a customer X similar to previous items rated highly by the same customer. For example, in an example of movies, you might recommend movies with the same actor or actors, director, genre, and so on. In the case of websites, blogs, or news, we might recommend articles with similar content or on similar topics. In the case of people recommendations, we might recommend people with many common friends to each other. So here's our plan of action. We're going to start with the user and find out a set of items the user likes using both explicit and implicit data. For example, we might look at the items that the user has rated highly and the set of items the user has purchased. And for each of those items, we are going to build an item profile. An item profile is a description of the item. For example, in this case, we are dealing with geometric shapes. And let's say the user likes a red circle and a red triangle. We might build item profiles that say that the user likes red items, right? Or that a user likes circles, for instance. And from these item profiles, we are going to infer a user profile. The user profile infers the likes of the user from the profiles of the item the user likes. Because the user here likes a red circle and a red triangle, we infer that the user likes the color red. They like circles and they like triangles. Now, once we have a profile of the user, we can then match that against the catalog and recommend other items to the user. So let's say the catalog has a bunch of items in it. Some of those items are red, so we can recommend those to the user. So let's look at how to build these item profiles. For each item, we want to create an item profile, which we can then use to build user profiles. So the profile is a set of features about the item. In the case of movies, for instance, the item profile might include author, title, actor, director, and so on. In the case of images and videos, we might use metadata and tags. In the case of people, the item profile might be a set of friends of the user. Even though the item profile is a set of features, it's often convenient to think of it as a vector. The vector could be either Boolean or real valued, and there's one entry per feature. For example, in the case of movies, the item profile might be a Boolean vector, and there's a 0 or a 1 for each actor, director, and so on, depending on whether that actor or that director actually participated in that movie. So let's look at the special case of text. For example, we might be recommending news articles. Now, what's the item profile in this case? The simplest item profile in this case is to pick the set of important words in the document or the item. How do you pick the important words in the item? The usual heuristic that we get from text mining is a technique called TF-IDF, or term frequency inverse document frequency. Many of you may have come across TF-IDF in the context of information retrieval, but for those of you who have not, here's a quick refresher. Let's say we are looking at a document or item J, and we are computing the score for term or feature I. The term frequency, TF-IJ, for feature I in document J is just the number of times the feature I appears in document J divided by the maximum number of times that same feature appears in any document. For example, let's say the feature is a certain word, the word apple. And in the document that we're looking at, the word apple appears 5 times. But there's another document where the word apple appears 23 times. And this is the maximum number of times the word apple appears in any document at all. Then the term frequency, TF-IJ, is 5 divided by 23. Now, I'm glossing over the fact that we need to normalize TF to account for the fact that document lengths are different. Let's just ignore that for the moment. Now, the term frequency captures the number of times a term appears in a document. Intuitively, the more often a term appears in a document, the more important a feature it is. For example, if a document mentions the word apple 5 times, the word apple is more important in that document than another document that just mentions it once. But how do you compare the weight of different terms? For example, a rare word appearing just a couple of times might be more important than a more common word like the appearing thousands of times. This is where the document frequency comes in. Let Ni be the number of documents that mention the term I, and let N be the total number of documents in the whole system. The inverse document frequency for the term I is obtained by dividing N by Ni, the number of documents that mention the term I, and then taking the logarithm of that fraction. Notice that the more common a term, the larger Ni, and the larger Ni, the lower the IDF. The IDF function ensures, gives a lower weight to more common words and a higher weight to rarer words. So if you put these two pieces together, the TF-IDF score of feature I for document J is obtained by multiplying the term frequency and the IDF. So given a document, you compute the TF-IDF scores for every term in the document. And then you sort all the terms in the document by their TF-IDF scores. And then you have some kind of threshold, or you might pick the set of words with the highest TF-IDF scores in the document together with their scores, and that would be the doc profile. So in this case, the doc profile is a real valued vector as opposed to a Boolean vector. Now that you have item profiles, our next task is to construct user profiles. Let's say we have a user who has rated items with profiles I1 through In. Now remember, I1 through In are our vectors. Of entries. Let's say this I1, this I2, I3, and so on. And here's In. These are, each is a vector in a high-dimensional space with many, many entries. Now, the simplest way to construct a user profile from a set of item profiles is just to average the item profiles. Here, N is the total number of item profiles. So if I take all the item profiles in the users, of all the items the user has rated, and then take their average, that would be a simplest way of constructing a user profile. Now, this doesn't take into account that the user liked certain items more than others. So in that case, we might want to use a weighted average, where the weight is equal to the rating given by the user for each item. Then you would have a weighted average item profile. A variant of this is to normalize these weights using the average rating of the user. And we'll see an example that makes this idea clear. And of course, much more sophisticated aggregations are possible. Here we're only looking at some very simple examples. Let's look at an example that that will clarify weighted average item profiles and how to normalize weights. Let's start with an example of a Boolean utility matrix. What's a Boolean utility matrix? All we have is information of whether a user purchased an item or not, for example. So each entry is either a 0 or a 1. Let's say the items are movies and the only feature is actor. The item profile in this case is a vector with 0 or 1 for each actor. 0 if that actor did not appear in that movie, and 1 if that actor appeared in that movie. Suppose user X has watched 5 movies, and 2 of those movies feature actor A, and 3 of those movies feature actor B. Now, the simplest user profile is just the mean of the item profiles. Now, remember, there are 5 vectors, and 2 of those have a 1 for feature A. And so the weight of feature A is going to be 2 divided by the total number of item profiles, which is 5, which is 0.4. and the weight of feature B correspondingly is going to be 3 by 5. Let's look at a more complex example with star ratings. Suppose we have star ratings in the range 1 to 5, and the user has once again watched 5 movies, and there are 2 movies starring actor A and 3 movies starring actor B. The movies that actor A starred in, the user rated 3 and 5, whereas the movie that actor B acted in, the user rated 1, 2, and 4. So since we have 5-star ratings and the user gives lower ratings for movies they didn't like and higher ratings for movies they liked, it's somewhat apparent from these ratings that the user liked at least one of the movies from actor A and one of the movies from actor B, but they really didn't like 2 of actor B's movies, the ones that were rated 1 and 2. 1 and 2 are in fact negative ratings, not positive ratings, and we'd like to capture this fact. The idea of normalizing ratings helps us capture the idea that some ratings are actually negative ratings and some are positive ratings. But the baseline, users are very different from each other. Some users are just more generous in their ratings than others. So for user A, for instance, a 4 might be a wildly positive rating, whereas for another user, 4 might just be an average rating. To sort of capture this idea, we're going to baseline each user's ratings by their average rating. So in this case, this user's average rating is a 3. If you average all the 5 ratings that the user has provided, the average rating is a 3. And so what we're going to do is to subtract the average rating from each of the individual movie ratings. So in this case, the movies with actor A, the normalized ratings in that case, instead of 3 and 5, become 0 and plus 2. And for actor B, the normalized ratings become -2, -1, and +1. Notice that this captures the intuition that the user did not like the first 2 movies with actor B, whereas he really liked the second movie with actor A, whereas the first movie with actor A was kind of an average movie. Once you do this normalization, then you can compute the profile weights. But in this case, we divide not by the total number of movies, but by the total number of movies with a specific feature. So in this case, there are 2 movies with actor A, and profile weight for actor A, the feature actor A, is 0 plus 2 divided by 2, which is 1. And similarly, the feature actor B has a profile weight of -2 by 3. This indicates a mild positive preference for actor A and a mild negative preference for actor B. Now that we have user profiles and item profiles, the next task is to recommend certain items to the user. The key step in this is to take a pair of user profile and item profile and figure out what the rating for that user and item pair is likely to be. Remember that both the user profile and the item profile are vectors in a high-dimensional space. In this case, I've shown them in a 2-dimensional space, but in reality, of course, they're embedded in a much higher dimensional space. You might recall from a prior lecture that when you have vectors in a higher dimensional space, a good distance metric between the pair of vectors is the angle theta between the pair of vectors. In particular, you can estimate the angle using the cosine formula. The cosine of theta, the angle between the 2 vectors, is given by the dot product of the 2 vectors divided by the product of their magnitudes. And this distance, in this case, we'll call this the cosine similarity between the user X and the item I. Now, technically, the cosine distance is actually the angle theta and not the cosine of the angle. Right? The cosine distance, as we studied in an earlier lecture, is the angle theta, and the cosine similarity is the angle 180 minus theta. Now, the smaller the angle, the more similar the item X and the more similar the user X and the item I are, and therefore the similarity 180 minus theta is going to be larger. But for convenience, we're going to actually use the cosine of theta as our similarity measure. Notice that as the angle theta becomes smaller, cos theta becomes larger. And as the angle theta becomes larger and larger, the cosine becomes smaller and smaller. In fact, as theta becomes greater than 90, the cosine of theta becomes negative. And so this captures the intuition that as the angle becomes smaller and smaller, x and I are more and more similar to each other. And it's more likely that x will give a high rating to item I. So the way we make predictions is as follows. Given the user x, we compute the cosine similarity between that user and all the items in the catalog. And then we pick the items with the highest cosine similarity and recommend those to the user. So that's the theory of content-based recommendations. Now let's look at some of the pros and cons of the content-based recommendation approach. The biggest pro of the content-based recommendation approach is that you don't need data about other users in order to make recommendations to a specific user. This turns out to be a very, very good thing because you can start working, making content-based recommendations from day one for your very first user. Another good thing about content-based recommendation is that you can recommend to users with very unique tastes. When we get to collaborative filtering, we'll see that in collaborative filtering, to make recommendations to a user, we need to find other similar users. The problem with that is that if there's a user with very unique or idiosyncratic tastes, there may not be any other similar users. Whereas a content-based approach is able to deal naturally with this, with the fact that you can make, user can have very unique tastes as long as we can build item profiles for the item that the user likes and a user profile for the user based on that, we can make recommendations to that user. A third pro is that we are able to recommend new and unpopular items. Now, when a new item comes in, we don't need any ratings from users to build the item profile. The item profile depends entirely on the features of the items and not on how other users rated the item. So we don't have a so-called first rater problem that we'll see in the collaborative filtering approach. We can make recommendations for an item as soon as it becomes available. And finally, whenever the content-based approach makes a recommendation, you can provide an explanation to the user for why a certain item was recommended. In particular, you can just list the content features that caused the item to be recommended. For example, if you recommend a news article to a user, for example, using a content-based approach, you might be able to say, look, in the past, you've spent a lot of time reading articles that mention Syria, and that's why I'm recommending this article on Syria to you. So these are some of the pros of the content-based approach, but now let's look at the cons. The most important problem or the most serious problem with the content-based approach is that finding the appropriate features is very, very hard. For example, how do you find features for images or movies or music? Now, in the case of movies, we suggested a set of features that include actors and directors and so on. But it turns out that movies often cross genres, and users are not very often loyal to specific actors or directors. The similar case with music, it's very hard to sort of box music into specific genres and musicians and so on. And images, of course, the features are very, very hard to find. So in general, finding appropriate features to make content-based approaches work turns out to be a very, very hard problem. And this is the main reason why the content-based approach is not more popular. The second problem is one of over-specialization. Remember, the user profile is built using the item profiles of the items that the user has rated or purchased. Now, because of this, if a user has never rated a certain kind of movie or a certain genre of movie, he will never be recommended a movie in that genre, for example, or he'll never be recommended a piece of music that's outside his previous preferences. In general, people might have multiple interests and might express only some of them in the past. And so it's hard to, so it's very easy this way to miss recommending interesting items to users because you don't have enough data on the user. Another serious problem of the content-based approach is that it's unable to exploit the quality judgments of other users. For example, there might be a certain video or a movie that's widely popular across a wide cross-section of users. However, the current user has not expressed interest in that kind of movie, and therefore the content-based approach will never recommend that movie to that user. The final problem that we have with the content-based approach is one of a cold start problem for new users. Remember, the user profile is built by aggregating item profiles of the items the user has rated. When you have a new user, the new user has not rated any items, and so there is no user profile. So there is a challenging problem of how to build a user profile for a new user. In most practical situations, new users start with most recommender systems start off new users with some kind of average profile based on a system-wide average. And then over time, the user profile evolves as the user rates more and more items and becomes more individualized to the user.